So you all have an idea about what mean, median, mode is, what skewness, kurtosis stands for, what is your range, your dispersion, measures of dispersion, standard deviation, variance and all. So we have a basic idea about how do we start analyzing. What is a sample, what is a population. Sample population के ऊपर में I need to do more. उसके ऊपर में I'll discuss a little more. In fact, mean, median, mode को भी. So एक बार book में आ जाते हैं एक बार. Let me just wind up with the first 2-3 LOSs. First LOS देखिए. Statistics का definition दिया हुआ है, don't bother please. Statistics is referring to data, methods to analyze, all that rubbish. Descriptive statistics क्या होता है? When you're looking at graphs and all, there are different kinds of graphs. You have your histogram, bar chart, and you know your polygons and all that. So you have different kinds of charts and all that you can study and analyze. That is descriptive statistics, because you're trying to analyze, you're trying to study, you're trying to look at how the trends are, how the data has been arranged. Next paragraph, inferential statistics. We will be looking at that when we go to the next few chapters, hypothesis testing and all, where you will be studying the sample and you will try to analyze or you will try to make projections about the population and all. That becomes inferential statistics, because you're trying to draw conclusions, you're trying to draw inferences, you're trying to draw analysis from the basis, on the basis of the past data about something called a population, about a larger set of data. So you will study a sample and you will extrapolate it. You will try to make comments about the larger chunk. Suppose you're supposed to buy, let's say you're going to buy 2000 units of shirt. Suppose you're a wholesaler. What you do is you get sample of 20 pieces, you look at the sample, you inspect the sample, and on the basis of that you place the order, because you think that the 2000 pieces will be exactly like the 20. So you study the sample and you try to extrapolate it, you try to analyze the population, the whole chunk of data accordingly. So that's what we're doing over here. Now, measures of central tendency. Come to the measures of central tendency. Come to population mean and sample mean. See, there is your population mean and sample mean given. Now don't bother about the population and sample part right now. In the next reading, we will discuss the whole set of population mean, sample mean, population SD, sample SD. So don't bother about it. Just understand mean as it is. That is your averages, summation of x divided by n. Don't differentiate between a population mean and sample mean right now. I will cover that portion in the next reading. I will cover that portion in the next reading. So just don't bother about it right now. Now when you're looking at mean, we need to discuss the arithmetic mean, geometric mean and harmonic mean over here. Formulas are very simple. Arithmetic mean is what you actually know, your basic average, that is you're summing up all the observations divided by n. Geometric mean would be x1 into x2 into x3 till xn whole to the power 1 by n. I'll tell you the application. I'll talk about the application of each. Harmonic mean would be n divided by sigma 1 by x. You will not have to learn the formulas. You will just have to understand the logic behind it. Suppose I've invested in stock A, B, C and D. Suppose I invested in stock A, B, C and D. I ended up investing, let's say $100 each in each of the 4 stocks. This stock is generating the return in percentage, is generating 10% return, 12% return, 14% return, 16% return. So on 100 you earn 10, 12, 14 and 16. Your total income generated would be 52. You earned this 52 on a 400 investment, so your average return is going to be 13%. This is very simple. That's your average return. Now say for example, I invested in stock. I invested in one stock. Say suppose I invested in one stock. That one stock generated a return of 10% in the first year, 12% in the second year, 14% in the third year and 16% in the fourth year. If I invest $1 over here, that becomes 1.10 over here, that becomes 1.10 into 1.12, because this amount is now invested and you're generating 12% on that. That becomes into 1.14 into 1.16 by the end of 4th year. Because you invested 1, that becomes 1.1 times. Now that becomes 1.12 times. Now that becomes 1.14 times. Now that becomes 1.16 times. Is that fine? Is that correct, everybody? Now, what if I want to find out a rate R which when compounded for all the 4 years generates the same value? So instead of earning 10, 12, 14 and 16, what if I was earning the same average rate? So I want to calculate this average now. What if I was earning one particular average rate? What would be that average rate? So instead of earning 10, 12, 14, 16, now if it's suppose 20 years, who's going to sit and analyze 20 values? I mean, what do you understand by that? Give me the average return. What it was an X% per annum compounded, like it was an X% in all the years. So let's say I equate this, let's say at 1 plus R to the power 4, so that R will be the average rate. Now R is going to be 1.10 into 1.12 into 1.14 into 1.16 whole to the power 1/4 minus 1. So basically 1 becomes this much in 4 years. So 1 year में कितना? 1 year में कितना बनेगा? To the power 1/4 minus 1 is the average rate portion, and we are just equating it. So if your returns are 10, 12, 14, 16% on a year-on-year basis, what is the average return for every year, which when compounded will give you the same result? तो या तो 10, 12, 14, 16% return generate करो, या फिर ये R% पे 4 years के लिए invest करो. You're gonna get the same outcome, right? Because इससे भी यही आएगा, and इससे भी यही आएगा. That is how we are calculating R. बोलो, समझ में आया? So this R becomes your geometric mean now. You're taking x1 into x2 into x3 into x4 whole to the power 1/4 to find out what 1 becomes on an average in 1 year, and minus 1. So when you're investing in multiple stocks, you can take arithmetic mean. When you're investing in one stock for multiple years, you should be using geometric mean. समझ में आया difference दोनों का? Of course, it's not going to be equal to 13%. इसका जो आंसर आएगा वो of course 13 नहीं आएगा, because the compounding is happening over here. You're investing in one stock for multiple years, you'll be using geometric mean. When you're investing in multiple stocks for 1 year, you'll rather be better off using an arithmetic mean. Following this, everybody? When you're looking at harmonic mean, you don't need the formula, you don't need to learn the formula. एक ऐसे basic है, since AMGM कर रहे हैं तो HM बता दे रहा हूँ. Harmonic mean क्या होगा? Suppose you're investing $100 or $1,000 in 3 stocks. Amount invested. The price that you're investing is at, let's say, 15, 20, 40. Let me make it 10. So stock price is 10, 20 and 40. I want to find out the average price of the investment. Average price कैसे निकलेगा? आपका total investment by total number of shares will give you the average price per share. The total investment divided by the total number of shares will give you the average price per share. Now total investment will be 3 into 1000. That is the total investment. Total number of shares will be 1000 by 10 is the number of shares, plus 1000 by 20 plus 1000 by 40. That should be the total number of shares. What if I take 1000 common? This, which is equal to n number of observation by summation of 1 by x. So an application of harmonic mean could be where you have equal dollar invested in all the stocks, what is the average price per stock? So when you're investing in one stock for multiple years, GM, when you're investing in multiple stocks for a year, you go for an AM. Where you want to calculate, you have equal dollar invested in all the stocks and you want to calculate the average price per share, you can go for HM. HM unimportant, not relevant, you can leave it out. I'm just doing it because we have AM, GM and HM all together. Right, everyone? Everybody's comfortable till here? Alright, one more variation. So you can just copy an example of each. Just do that, then I'll make a little variation and I'll make you write those 3 statements. I'll give you the 3 statements. So just take this one, then you take the example AM, GM, HM, and I'll do a little bit of variation here as well. Just take this quickly, please. Are we done? Everyone? Just take down one more. Just write the AM, GM, HM and write down. When you invest in multiple stocks for 1 year, take this down. AM, GM, HM. When you invest in multiple stocks for 1 year, under AM. When you invest in multiple stocks for 1 year, AM. Second, below GM, invest in one stock for multiple years. Investing in one stock for multiple years. Invest in multiple stocks for multiple years. Invest in one stock for multiple years. And the last one, HM, invest equal dollar amounts to calculate the average price. Invest equal dollar amounts in multiple stocks and calculating its average price. Invest equal dollar amounts in multiple stocks and calculating its average price. Done? Investing equal dollar amounts in multiple stocks and calculating its average price. That is HM. Everyone sure? Understood everything? Alright. Now just do one thing. Come back to the book. The example of population and sample mean is very simple. You're just calculating average. Don't worry about it. We'll cover it later. The line below that, if you can underline, if you can get to the first line below the example, population mean and sample mean are both AM. Population mean and sample means are both AM. Got that? Now look at the fourth bullet. Beside the fourth bullet, take this. Please understand, I have not taken the absolute value. Summation of all values x minus x bar is going to be 0. Obviously, because you've calculated all the deviations around x bar, and x bar is the average of x. So the total of x, if you have n observations, summation of all the x will be sigma x. And x bar, if you take x bar n times x bar is going to be equals to summation of x. X bar is equal to sigma x by n, right? So n into x bar is going to be summation x. So this has to be 0. That is the average point. So all the deviations, all the observations minus x bar is going to give you 0. The rest of the points are not that important. Next example, the paragraph below the next example, just observe that. Unusually large or small values can have a disproportionate effect on the computed value for AM. Underline large and small values and write outliers and write outliers. Unusually large or small values, that is outliers. Beside that, if you want, you can write disadvantage of AM, or you can write mean gets affected. AM gets affected by outliers but not median. Mean gets affected by outliers but not median. Mean gets affected by outliers but not median, and put a dash and write measured by skewness. Mean gets affected by outliers but not median, measured by skewness. Next to next line, AM uses all the information about the available observations. Very unimportant, it's just an advantage that AM is based on all the observations. Median is not. Median is just giving you the central value. Next paragraph, if you want, you can mark median as a midpoint of the data set where the data is arranged in ascending or descending order. The next paragraph, median is important because it is unaffected by the large outliers. So when you have large outliers, exceptional values in the data, median is going to be a better alternative. You've got very basic examples of median. You arrange the data in ascending order and then you take the centralmost value. So you can go through the examples yourself. I'm not bothering about it. See the second example if you want to. Now, if you look at the data set in the question, 30, 28, 25, 23, 21, 15, it's already arranged in the ascending order for you. Now, if you want to find out the central point, it cannot be 23, it cannot be 25. Because if you're taking 25%, there are 2 data points above but 3 below it. If you're taking 23%, there is 3 data points above and 2 below it. So the answer needs to be between 23 and 25. So we can simply take the average of 23 and 25, that becomes 24%. So it's very simple. So if you have even data sets, that is how you calculate median. It's very, very obvious. Mode is again simple. Occurs the data that occurs most frequently. Last line, it could be bimodal or trimodal. If you have more than one data that appears highest frequency, so if there's out of 1000 values, there is one observation that appears 50 times and there's another observation also that appears 50 times. Both are going to be the modes of the data and we'll call the data to be bimodal. Geometric mean, I hope, is fine now. You can look at the example. For the last 3 years, the returns have been minus 9.34%, 23.45 and 8.92. So that is $1 becomes, at the end of first year, it will become what? 0.9068, sorry, 0.9066 times 1 minus 9.34%. $1 will become how much? 0.9036 times, 0.9066 times. At the end of second year, it become into 1.2345 into 1.0892. That is what $1 becomes in 3 years. $1, sorry. At the end of first year, $1 will become 0.9066 times, then it becomes 1.2345 times, and in the next year it will become 1.0892 times. So $1 becomes this much in 3 years. So what will it become in 1 year? 1/3. So what is the interest component? -1. $1 becomes this much in 3 years, this much to the power 1/3 in 1 year, and -1 gives you the interest component. Is that fine? And the professor's note, you can cancel that professor's note and write this. If all observations are equal, then AM equals to GM equals to HM. Otherwise, AM is greater than GM is greater than HM. Arithmetic mean is greater than geometric mean is greater than harmonic mean. I'm deliberately trying to give you things in the form you have studied probably in class 11 and 12 because your attention becomes easier. So always studying the same thing from the same place. Don't study the same thing from 20 places. Follow one thing, study one thing, study in one format. And that is why please start making your own formula sheets so that you're looking at the formulas in your own handwriting. One, you get to practice a little bit because we understand the exams are MCQ and you'll have less practice in the written form. So write the formulas in your own handwriting, add a few things like, adding these things and all. So your book formula sheets and the formula sheets will not help you in this kind of stuff. So make your own formula sheets in your own handwriting. While you are studying, keep on adding. So, use different colors, add more data in that. So, on the exam day or before the exam, it will be very, very helpful. So, make your own formula sheets. Trust me, it's gonna help. Are we comfortable till here? Everyone? Sure? Understood everything? This completes this section.